Hello everyone, welcome to DEEPTHI Academy. In this one video, I will bring you some of the important case or source based type questions on the lesson Light Reflection and Refraction for the academic year 2021 and 22 10th standard, the term 1 examination. So let's start the video. Here is the first question. Rama wants to find out that the clear image of a window pane of her science laboratory at a distance of 15 centimeter from front of the lens. Right. She now tries to focus the building visible to her outside the window instead of a window pane without disturbing the lens. So this is the a statement we have, and we have to be read out and understand this paragraph. Then we can easily solve the questions related to this paragraph. So this is the source based or case based type questions. Now understand the question. Now let us see the question first. In which direction will she move the screw to obtain a sharp image of the building? So here they have given the four options. Now let I explain you what is the given the paragraph meaning. So here we have a convex lens, right? And the convex lens, it will always produces the real and inverted image, and that image is behind the lens. And here we have the positions. Depending on the positions of the object, the image is going to form. For example, if you take the object is at infinity, so the image is going to be form at focus, right? And if you kept the object beyond center of curvature, and the object is the image will form between f2 and f2 to f2, right? Here is f and here is 2f1. So if I kept the object beyond 2f1 or this first center of curvature, the image is going to form in between f2 and 2f2. So here, so depending on the position of the object, the image formation will be takes place depending on the position. Now here we have, now Rama wants to take the clear image of a window pane. Now it means, let's suppose that here somewhere we have a window, and the image of the window from the science laboratory at a distance of 15 centimeter, right? So let's suppose that the 15 centimeter somewhere here, right? Now she tries to focus the building visible to her outside the window. So outside the window means here the object, it is at infinity, right? Object, it is at infinity. So here, as the object it is at infinity, the image of the object, obviously it will form at f2, right? So here window is beyond 2f1, which means the image of the window will form between f2 and 2f2. Are you getting this one? Now just now see the question. Now we have without disturbing the lens, the image of the building we have to take. Now the question is what? In which direction will she move the screw to obtain the sharp image of the building? Now without disturbing this lens, she wanted to catch the image of the building. In which direction she is going to move the screen? Now that is a screw in the sense like we have to understand that the screen we have to move. So move always from it. Option B, move towards it. Keep in the same position or can't be decided. Let's suppose that here we have the screen at f2, right? For the object it is at infinity. Now if you wanted to, now the image or the object it is at beyond center of curvature, the image will form between f2 and 2f2. It means the screen should be placed here in order to get the image. So what we are doing here, we are just moving this screen towards the lens. Are you getting? The lens, it is a constant. We are not disturbing this one lens. Just we are moving the screen towards the lens in order to get the image of the object. So here the answer for this one question is we have to move the screen towards the lens. So the option B is the correct answer. Next question. What is the approximate focal length of the lens? The approximate focal length of the lens. You can see here, as in the previous question, already have drawn the rough diagram in order to understand. The focal length is 15 centimeter. Right? Now they are asking the approximate focal length. Here you can see the option A, infinity. It is not the approximate focal length of the lens. 10 centimeter, no, because already they have given 15 centimeter. And here we have option D, 30 centimeter will not be the approximate focal length. So here option C, the approximate focal length of the lens, is the correct answer. Next question. A student wants to project the image of a candle flame on the walls of a school laboratory by using the lens. Find out. So which type of lens should be used? So here, in order to get the image of a candle flame, here the convex lens has to be used in order to get the image of a candle flame, because the candle flame, that is the convex lens, is a converging lens, so it will always produces the real-line inverted image. Next question. The reflecting surface of a spherical mirror may be curved inwards or outwards. A spherical mirror whose reflecting surface is curved inwards, that is the faces towards the center of curvature, center of the sphere, is called a concave mirror, right? A spherical mirror whose reflecting surface is curved outwards is called a convex lens, a convex mirror. So here is the statement or the data regarding the question. So by using this one paragraph, we have to solve the number of questions. The first question is, a mirror with a surface then curves inwards like inside of a bowl. It is what? So obviously the curved inwards means the given lens or the given mirror is concave mirror. You can see in the figure also, curved or bulging inwards is a concave mirror. So the option A is the correct answer. Next question. Convex mirrors produce. So convex mirror will produce only virtual images, right? Convex mirror, only virtual images are produced by the convex mirrors. Next question. Convex mirrors are plane mirrors? No. Converging mirrors? No. Diverging mirrors? Yes. The convex mirrors are diverging mirror. Option C is the correct answer. A dentist uses a small dental mirror to help magnify teeth in your mouth. What type of mirror is this? So the dentist mirror is a concave mirror. Option A is the correct answer. Next question. While dealing with the reflection of light by the spherical mirrors, we shall follow a set of sign conventions that is called as new Cartesian sign convention, right? In this convention, the pole of a mirror is taken as the origin, right? The principal axis of the mirror is taken as x-axis of the coordinate system, right? In a spherical mirror, the distance of the object from its pole, it is called as the object distance. Okay, right? The distance of the image from the pole, it is called as image distance, represented with the letter V. Okay, right? Now the magnification produced by the spherical mirror gives the relative extent to which the image of the object is magnified with respect to the object. Okay, it is expressed as the ratio of height of the image to the height of the object. So the definition they have mentioned for the magnification, and it is usually represented with by the small letter m. And here we can see in the diagram the sign conventions rules they have represented in a diagram. That is, we have the direction of light, the incident light, and this is the opposite direction. The distances which are opposite to the direction of light are taken as negative, and the distances towards in the direction of light are taken as positive. The distances above the principal axis are taken as positive, and the distances below the principal axis are taken as negative. So this is the question, the paragraph detailed information we have. So based on this one paragraph, we have the number of questions. So let's solve this one. First question. Magnification produced by a rear view mirror is a rear view mirror fitted in vehicles. So magnification of a rear view mirror, that is the convex mirror, it is we know that the convex mirror produces always virtual and erect image, and it is diminished. Diminished means the magnification is less than 1. Okay, magnification diminished means the magnification is less than 1. So here we have the option A, that is less than 1 is the correct answer. Next question. Focal length of a concave mirror is. So here we have a concave mirror. So focus and center of curvature. So let's suppose that a ray of light incident on the mirror, and after reflection it passes through the principal focus, and here, so this is the focal length, right? The distance from pole to the focus, it is the focal length. So focal length of a concave mirror, option A, negative, positive, depends on the position of the object, depends on the position of the image. So here, according to the sign convention, the distances opposite to the direction of light are taken as negative. So here option A is the correct answer. Next question. Spherical mirror and spherical lens. So here we have spherical mirror and spherical lens. Each of have a focal length minus 10 centimeter, right? The mirror and the lens are likely to be. So the mirror, we have to find out the mirror and the lens, as the focal length is minus 10. So first I will tell you the thing that regarding the concave mirror. So it is focal, it is focus, it is center of curvature. So ray of light incident on the concave mirror. So after reflection it will pass through the focus. So this focal length, as for the sign convention, it is negative. Fine. So the focal length they have mentioned minus 10. So the first thing is the given mirror is a concave mirror, right? And also for the lens, we know that the concave lens. So the concave lens is the diverging lens. Concave lens is what? It is a diverging lens, and obviously the focal focus for the diverging lens is left side, and here left side distances are negative. So which means the option A, that is the both the mirror and the lens are concave. Option A is the correct answer. Next question. If the image is formed in front of the mirror, then the image distance will be so here, as the image is that is the image formed in front of the mirror, so the image distance, option A, we have positive or negative, or depending on the size of the object. Option B, we have neither positive nor negative. Option C, we have positive. Option D, we have negative. So the image distance, as the image is formed in front of the mirror. So the image is forming in front of the mirror. If I have taken the concave mirror, so the image is forming in front of the mirror, right? So the image distance, so this distance is what? This distance is negative. So the option D is the correct answer. Next question. Sumati wanted to see the stars of the night sky, right? She knows that the needs of a telescope to see those distant stars, right? So in order to see the distant stars, we need the telescope, right? She finds out that the telescopes which are made up of lenses, right? You can see here in the image, it contains lenses L1 and L2, are called as reflecting telescope, and the ones which are made up of mirrors are called as reflecting telescopes. Okay, now so she decided to make a refracting telescope. So refracting telescope means which contains the lens. Reflecting telescope means which contains the mirror. So we are getting something idea while reading the paragraph, right? Now she bought two lenses, L1 and L2, L1 and L2, and L1 and L2, out of which L1 was bigger, L1 was bigger and L2 was smaller. So here smaller L2 was smaller. The larger lens gathers and bends the light, while the smaller lens magnifies the image, right? Big thick lenses are more powerful, right? So to see far away, she needed a big powerful lens. Unfortunately, she realized that a big lens is very heavy. Okay, heavy lenses are hard to make and difficult to hold in the right place. Okay, also since the light is passing through the lens, the surface of the lens has to be extremely smooth, right? Any flaws in the lens will change the image, right? It would be like looking through a dirty window. So this the paragraph we need to understand first, and related to this paragraph we have the number of questions. So here we have Sumati. She wanted to see the stars at the night in the sky, and she's having the telescope. Okay, so she's having the telescope, and the telescope contains the lenses L1 and L2. L1 lens is bigger and L2 is smaller. So here we have refracting surfaces. The telescope which contains lens, it is called as refracting telescopes, and the telescope which contains mirror, that is called as a reflecting telescope. So we have something data here. So according to this one data, we need to solve some questions. So check that one. So the first question, based on the diagram shown, right, what kind of lenses would Sumati need to make telescope? So here, as for the data, in order to make the telescope, she needs which type of lenses? She needs convex lenses. So direct answer that we can choose that by using the convex lens, she wanted to make the telescope. Next question, if the powers of the lenses L1 and L2 are in the ratio 4:1, right, what would be the ratio of focal length L1 and L2? So as we know that what they have given, the relation, we know that power is equal to 1 by F. Okay, and they have given the ratio of the powers, that is two lenses P1 and P2. They have given the ratio 4:1, which means 4 divided by 1. Correct? Now, what would be the ratio of focal length? Now we want the ratio of the focal length, right? So here the P1 can be written as 1 by F1 divided by P2 can be written as 1 by F2, and this is 4 by 1 as it is. Okay, now take this F2 to the numerator, so you will get F2 divided by F1 is equal to 4 divided by 1 as it is. So the ratio of F1 and F2 would be 1:4. So here we have the option B, 1:4 is the correct answer. Next question, what is the formula for magnification obtained with the lens? So we have the formula for the magnification, that is, it is the ratio of height of image to the height of the object, that is magnification M is equal to H dash divided by H. So option A is the correct answer. Next question, Sumati did some preliminary experiment with the lenses and found that the magnification of the eyepiece L2 is 3. Okay, so they have given the magnification is 3. If in her experiment with L2 she found an image 24 centimeter from the lens, okay, they have given image distance is 24 centimeter. Okay, at what distance did she put the object? So we have to calculate we have to calculate U. So we know the formula, M is equal to V by U. So M they have given 3, V they have given 24, right? U we have to calculate. Simplify this one, you will get U is equal to 8 centimeter. So the option C is the correct answer.